Jupiter's volume is over 1,300 times that of the Earth. At that size, it really is a giant planet. In fact, scientists classify Jupiter, Saturn, Uranus, and Neptune all as giant planets, or outer planets in our solar system. Our next guest takes us on a tour of these giants and shows us how their design point to God's creation of our solar system. Coming up next on Origins, the outer planets with Dr. Jason Lisle. Hello, my friends, and welcome to Origins. My name's Donn Chapman. It's such a privilege to be your host. During this program, we showcase interesting guests who present evidence from science along with other important facts, validating the truth of creation and the accuracy of the Bible. Today's guest, Dr. Jason Lisle, has a PhD in astrophysics from the University of Colorado and is the author of Taking Back Astronomy, The Heavens Declare Creation. He was instrumental in the development of the planetarium at the Creation Museum in Kentucky, and he currently directs research for the Institute for Creation Research in Dallas, Texas. Dr. Lisle, we're thrilled you're here with us today.
Thanks, good to be here.
Great to have you. Now, we're going to visit the part of the solar system that I know the least about, the outer planets today.
I'm excited probably true of most people, I think. I think we tend to think of planets, we tend to think of Earth, but the outer planets are not very much like Earth at all, other than they're round. Other than that, there's not a whole lot of similarity there. And we start with Jupiter, which is the largest planet of our solar system, and it's the next one out. So we're just going out from the sun. So you got Mercury, Venus, Earth, Mars, and then Jupiter is the next one out. And it's about 5 times farther away from the sun than the Earth is, just to give you a feel for it. So we're no longer dealing with these things that are relatively close to the sun. It's far away. And because of that, it takes something like 16 years.
Even though it's next out from Mars, it's a fur piece.
Yes, it is. That's right. That's right. Now, some of the asteroids are in between those two, and they kind of fill that gap. But it's quite a bit further away from the sun, and therefore its year is very long. It takes a long time for it to orbit around the sun. And so here we have an image of Jupiter, and you can see what it looks like there. Jupiter is a ball of gas, and so it doesn't really have a solid surface like these other, the inner planets do. It's just a ball of gas, and people say, well, why is it a sphere like that? Well, its own gravity holds it together. And people think gas has gravity. It does. Everything that has mass has gravity. And gas has mass, therefore it has a little bit of gravity to it. And once you collect that gas into a sphere, its own gravity will hold it together. And we think that gas probably becomes liquid at some point just because of the pressure. And Jupiter may have a rocky core. We don't really know about that for sure. But in any case, it's mostly gas.
Now, when you tell us that it's gas, how do you know that, sir?
Yeah, well, there's a number of ways, but one of the main is we know its density. And the way we know that is there are moons that orbit Jupiter, and when something is in orbit around a planet, the period of that object will tell you how much gravity the planet has, which tells you how much mass it has. And we know how big Jupiter is because we can see it, and so you know the volume. And you take the volume, and you take the mass divided by volume gives you the density, and that tells you something about the substance that's making it. It can't be iron because it would be much more dense than that. And so we actually know that Jupiter's made of hydrogen and helium gas. Those are the 2 lightest elements. And it's got some other compounds as well. It's got some ammonia and methane and things like that.
So, you know, you're an astronomer, but you're also a mathematician, and math is very key in really what we can learn about the other planets, isn't it?
It is. It's the language of God, I like to call it.
Wow.
And it's
That's high praise.
The reason that we can do astronomy is because of mathematics. God has organized the universe in such a way that it obeys nice, neat little mathematical equations that human minds can understand, and so on. And so we're able to discover these things because of mathematics. Young students can learn the properties of the planets and things like that. But if they want to do science, they have to learn mathematics.
Did you hear that, young people? When you're listening, learn your math because it will open doors to you to study science.
Absolutely. And so it's because of mathematical techniques and science that we're able to learn what we're able to learn about Jupiter. Notice here that it's got these stripes along its surface.
Yeah.
Those are belts. The dark ones are belts. The light ones are zones. So belts and zones. And those are basically clouds. Jupiter is a ball of gas, and the gases are not all transparent. Like the Earth's sky is mostly transparent, but we have clouds. Well, those are clouds on Jupiter. Now, on Earth, Our clouds tend to get, they go over the land masses and they get distorted, and that distorts the jet streams. On Jupiter, there's no land mass.
Yeah.
And so the clouds tend to form complete bands surrounding the planet, and that's what you're seeing there. You got, and then the zones, I think, are a little higher up, and they're obscuring the layers below it, and then in the belts you're able to see a little deeper into the planet there. And so that's what you're seeing. You're seeing different layers of Jupiter's atmosphere. And
are there poles on Jupiter?
yeah, it's got polar caps, but they're not ice caps. They're balls. They're just gas,
They're
just like everything
gas,
else.
everything
And in fact, we can kind of
spin it around.
Spin around here and take a look, and you can see what the polar regions look like. And you can see the stripes they're not as apparent in the polar regions as they are near the equator. You have those two equatorial stripes, were the really prominent ones. And you can see these in a small telescope. Anyone that has a small telescope, you point it at Jupiter, you will see, if nothing else, you will see at least two stripes. That's where they are. And they're dynamic. They change year after year a little bit, but they're almost always there. Almost always. Every now and then one of them will go away. That happened just a few years ago. One of the belts disappeared, and then it came back about a year later. So it's dynamic. It's weather, but it's very different than the kind of weather that we see on the Earth. So it's an interesting planet. It's about 10 times the size of the Earth. You could line up at least 10 Earths across Jupiter just to give you a feel for how big this thing is. It's enormous. And it is the largest planet in our solar system. Nothing else comes close to Jupiter. Saturn's the second biggest. If we speed up time, we rotate it around, you can see that Jupiter rotates. It actually rotates very quickly. It takes only 10 hours for it to spin once, remarkably. And you can see that it's got this big red spot right there, a great red spot, which astronomers call the Great Red Spot, because we're not very creative apparently. And that's basically a giant cyclone, like a hurricane. And it's a big storm on Jupiter. Yeah.
Kind of a permanent storm.
It's a permanent one, yeah. Now, hurricanes on the Earth, they'll move over landmass, and they lose their power source, which is the ocean, and that cuts them off, and they dissipate. On Jupiter, there's no landmass.
So there's nothing to stop it.
Nothing to stop it, exactly.
It just
keeps going. It keeps going, apparently.
Isn't that amazing?
Yeah.
Think of that, a storm that never ends.
Absolutely. And we know it's been there for at least 300 years, but it might have been there since creation, for all we know. But it's been there since we've had telescopes that have been high quality enough to see it. So it's rather remarkable. Now it'll shrink and grow, and it'll move a little bit back and left and right. It'll move left and right, but not up and down so much, because it's sandwiched in between that lower belt and the zone below it. So it's kind of locked in there. But it's fun to watch for that, and you can see it in a small telescope sometimes. It's a little tricky to see, and keep in mind that 50% of the time it's on the other side of Jupiter, and so you don't always see it. And in fact, if it's even close to the side, like that. I mean, you can see it here because this is a high-resolution image, but in a telescope, you wouldn't be able to see it if it was over there. It would just blend in. It has to be pretty close to center for you to see it in a small telescope.
There it is, yeah.
So it's a fascinating planet, and it has all kinds of moons that orbit around it too. And so I'd like to show you some of these moons. In fact, it has 4 big ones that you can see even in a small telescope, or in fact, even in binoculars. You look at Jupiter in binoculars, you'll always see these little starlets right next to it. And those are its moons. And so let's take a look at some of these. Let me turn on their names here so I can see them. The innermost, and my very favorite moon in the solar system, is Io, or Io, sometimes it's called. And I love this little moon, and it looks to me kind of like a pizza. That's why I like it. So or maybe an orange that you left in the refrigerator for too long and it kind of has decayed or something. But isn't that a weird-looking little moon?
It is.
It's just about the same size as Earth's moon, so it's pretty big as moons go. And you can see it's just pockmarked with little objects there. That was a little lunar eclipse as it went by Jupiter. But you can see there all those little pockmarks. Those are not impact craters. They are, in fact, volcanoes.
Oh.
Yeah, and they're active.
Now,
They're
even
active.
though the planet is gas, this is solid.
That's right. All moons are solid. And it's a good,
All moons are
solid. And it's a good question, because I have had people ask, can you have gaseous moons? Theoretically, but God apparently chose to create none, at least in our solar system.
That we've seen.
Yeah. They'd have to be pretty big, and I guess moons in our solar system probably don't get big enough. Something else you can see that's interesting too, let me back out here a little bit. If you notice, there's Io, and then you see on Jupiter, you can see Io's shadow. And that is something else that you can see in a small telescope. A lot of times you'll see these little black welts on Jupiter, and that's one of the shadows of the moons. And in fact, you're seeing 2 of them there. You're seeing Io and the shadow of this other moon out here, that's probably Ganymede. So, but Io has active volcanoes, and they're very, very active. In fact, when the Voyager spacecraft, there's 2 Voyagers that flew past Jupiter and past its moon Io, and they saw, I think, 9 volcanoes going off simultaneously.
Oh, wow.
It's incredibly active, and we think that's because it orbits in between Jupiter and the next moon out, and we think that stretches it and kind of causes it to heat up the interior of Io, and so it's giving off these volcanoes all the time. It's a fascinating little moon. So
It
really
really
interesting
is.
little thing. And a lot of fun. Of course, let me show you this again too. Those that were watching carefully saw this before, but if we let it rotate around, you can see it keeps the same side pointed toward Jupiter, just like our moon does. In fact, all large moons do that. They keep their same side. And there it goes blank because it's in Jupiter's shadow. How about that? And it comes out the other side and so on. And again, always casts its shadow on Jupiter there when it's in front. So a fascinating little moon. So that's the innermost of the big four that you can see in a small telescope. That's the innermost of them. And these were discovered in 1610 by Galileo. He was the first person to see moons around other planets. Before then, we knew about Earth's moon, and that was it.
And this was the first one.
Yeah,
it was Jupiter's moons.
Jupiter's moons. He saw all four of them. Within the first few weeks, he saw all four of them. And so let's go to the next one out, which is Europa. And Europa is made of ice, basically. It's an ice moon. And you can see it's got these weird streaks along its surface. We don't really know what causes that, but it's interesting. And there's a lot of, it's like a frozen ocean with icebergs that are frozen in the ocean itself that's also frozen. So it's a really interesting little moon. This one's just a little smaller than our moon. It's the smallest of Jupiter's large four moons, so now, Europa.
You say ice, so is it water?
Some water ice, but some other types of ice too. I should mention that astronomers call anything ice that would be sort of gas or liquid at room temperature. If it's frozen, we call it ice. So ammonia, methane, things like that.
That's why I asked.
Those would also be ice.
It doesn't necessarily mean it was water. It could be other
could be other types of ice as well. Yep. And dry ice, things like that you see on Mars. Okay, the next one out. Satellites, there we go. The next one out is Ganymede. Ganymede is the largest moon in the solar system. And it's sort of fitting that the largest moon would belong to the largest planet. Sure. Jupiter's so big, it's actually bigger than the planet Mercury. And so if it orbited the sun directly, this would certainly be called a planet. It would not be called a moon. But because it orbits a planet, it's a moon.
By definition, if you orbit a planet, you're a moon.
Exactly. So there's Ganymede, the largest of the four big ones, the largest of any moon. And then we got another one, Callisto, which is a little bit further out still. And we'll take a look at this one too. It's sort of interesting because when I was a kid, and I remember looking at these fascinating little moons, and I'd already studied the planets, of course, and I knew about the planets, and then I started looking at these moons like a whole other solar system in a way, you know? A little solar system that orbits around Jupiter. So there's Callisto, the outermost of the four, and those are the ones you can see even in binoculars as little starlets, but we now have these wonderful images thanks to the Voyager spacecraft that flew past Jupiter. So really a wonderful planet. Now Jupiter has over 60 moons that are known.
Oh wow!
Yeah.
We just looked at 4, but there's a lot of them.
But most of them are small. They're kind of like Phobos and Deimos on Mars. Those two little moons that orbit Mars. And so what I'm going to do is turn on the names of all these moons so that you can see them, and I want to make sure that the orbits are turned on as well, so that you can see the orbits of these things. And there's the inner moons. You can see they all orbit kind of in the same plane, kind of like our solar system does, with all the planets orbiting in the same plane. And I think that's a design feature, actually, because if these moons are relatively large, and if they were orbiting sort of haphazardly, they might collide or they might come close and gravitationally perturb each other. But the outer moons of Jupiter, they kind of do what they want. You can see there's the outer moons of Jupiter, and they're all in. Now, each of those orbits is an ellipse. We know that from Kepler's laws. Everything orbits in ellipse, but they're just each ellipse has a different orientation. And so you can see that it looks almost like a beehive in terms of the way those moons are organized. And if we speed up time, we can actually watch these moons orbit. And you see the inner moons, nice, neat, almost circles, very well behaved. And we speed up time, we got to these outer moons, and we see that they just kind of do what they want.
And the reason for that, Jason?
I think it's a design feature. The inner ones have to be in the same plane in order to avoid collisions. But the outer moons, because there's so much space available to them, and because they're small and they don't have a lot of mass, God can put them in any sort of orbit, and it's nice and stable. It's not a problem. And some of these might even be captured asteroids that came too close to Jupiter and then got locked into orbit. And you can see a number of them orbit backwards even, which is interesting.
Yeah, at the same time. That's amazing.
It's like a little solar system, really.
It really is.
So Jupiter has its own little mini solar system. Okay, now the next planet out, probably everybody's favorite, is Saturn. Saturn's a little smaller than Jupiter. So Saturn is the second largest planet in the solar system.
Still huge.
And yeah, we'll rotate it around here so it looks like kind of what we're used to. And of course Saturn, the planet itself, it's kind of like a smaller, cooler Jupiter that doesn't have quite as many bands or belts and zones. You can see some faint belts there on Saturn and some zones, but they're fainter than they are on Jupiter. But the spectacular thing about Saturn, of course, is the ring system.
But this is also all gas.
It's also a gaseous planet, yeah. So you can't land on Saturn. There's nothing to land on.
Okay.
Of course, the rings are made of solid material. They're solid little particles of ice and rock that orbit around Saturn's equator. And so what you're seeing there, the rings basically are trillions of tiny little moonlets that encircle Saturn. So it's a fascinating planet, and those rings just make it absolutely stunning. Now, all the big planets have rings. Jupiter, Saturn, Uranus, Neptune, they all have rings. But only Saturns are thick enough that where we can see them easily from Earth. And that makes Saturn one of the most extraordinary objects to look at in a small telescope. And you can see these in a small telescope, not a problem.
Again, the artistry of God just jumps out at me when I look at
Absolutely.
that. God just says, let's make this different. Let's make it special.
Yeah. In fact, the reaction that most people have when they see Saturn for the first time in a telescope is, wow.
Yeah.
Wow. And then they look down the side like, are you tricking me, Dr. Lisle? Or, what are you doing here? No, it's real. That's really what it looks like. God really there's something extra special about this planet here.
And don't you think that's sort of the nature of God, that He makes things that when we look at them, we go, wow.
Yeah. And of course, this Saturn right here, most people, when they think of Saturn, they think of this. They think of the rings and everything. But for nearly 6,000 years, Saturn was just one of the little points of light in the sky. This was a little gem, a little surprise that God has given to us in recent times with the advent of technology. Wonderful little gift, too.
God is an amazing God, that He makes things like this. When I look at that, just in my little mind, I think of visiting Victoria Falls and saying, wow. I remember being in Alaska and watching the salmon jump over the waterfall and saying, wow. And God loves that. Of course, the greatest awe is when we see His character, when we see God for who He is in His majesty. And these things just reflect that glory of God.
Yeah.
We've got to take a break, but we'll be back we've still got our planet left, and we've got some tying this all up together. So don't you go away. We'll be right back. We are back with Dr. Jason Lisle, and when we left, we were looking at the splendor of Saturn with its ring. Continue to tell us about that.
Okay, well, there's so much that could be said about Saturn. It's really is a gem, and it's fun to look at with a telescope. I think we'll go to at least one of its moons. Now, it's got dozens and dozens of moons, just like Jupiter. But the one that you can see in a small telescope, or even in good binoculars, is the moon Titan. So we'll go to that one. And it is the second largest moon in the solar system. In fact, for a while, they thought it might be the largest, hence its name, Titan. It really is quite large. But that's because it has, in fact, a thick atmosphere, and that kind of puffs it out a little bit. So it's a little bit...
It has its own atmosphere.
Yeah. So it's the only moon that has a thick atmosphere. Some of the moons have a real thin one, but this one has a very thick atmosphere, an opaque atmosphere, so you can't see the surface. But again, we have been able to use some other techniques to penetrate the surface, and so we know that the surface looks something like that. And we think there might even be lakes of like methane or ethane, hydrocarbon-type lakes on this little moon. And so there's some evidence for that, which is really quite fascinating. But it does have that really thick atmosphere, and it's orange. It is an orange moon because of that, because of those hydrocarbons. So gasoline would be very inexpensive on Titan because that's kind of what it's made of.
Yeah.
On the other hand, oxygen would be expensive. So
Yes.
count your blessings.
It all evens out.
And of course, there's a lot more we could say about Saturn, but we need to move on. There's two other planets that we want to cover here briefly. And the planets Uranus and Neptune. Now, Uranus is really the only planet that was not known to antiquity. It was discovered more recently. William Herschel discovered the planet Uranus. And so it's one of the ones that's only been known in relatively modern times. And because it was discovered by an Englishman, it was named after, they changed it. They named it after a Greek god instead of a Roman god, of course, if you're into the nomenclature of those sorts of things. And the moons they named after Shakespearean characters in honor of England, because it's being an English planet, you see. And so there's the planet Uranus. And the interesting thing about Uranus, there's many interesting things, but one is it's tilted on its side. And so it actually rolls around the sun, you might say. So it spins sideways. Now again, in the secular view, all the planets really ought to be upright and spinning the same way and in the same direction. And we saw in a previous program, Venus is backwards. Well, Uranus is sideways, like that.
Amazing.
So it's really kind of fascinating. Another thing that's very interesting about Uranus is it has quite a strong magnetic field. And the magnetic field is not aligned with the rotation axis. On Earth, it's pretty close, which is why your compass points close to the North Pole, because the magnetic north is close to true north. Right. On the planet Uranus, it's way off. The magnetic axis and the rotation axis are very, very different. And that's kind of interesting. And again, I think that's an example of God just doing something a little different than the way the secularists would expect. But frankly, they wouldn't expect to have a magnetic field on this planet at all, because in their view, it's billions of years old. And as we saw previously, magnetic fields naturally decay with time. They can't last billions of years. And so the fact that you have a magnetic field, a pretty strong one on this planet, strong enough to have northern lights even, aurora borealis, the fact that it's that strong is a strong indicator that this planet is not billions of years old. It's consistent with a few thousand years, something like the biblical age of 6,000 years.
Substance of this planet?
It's made up of a lot of the hydrogen and helium, a lot of those things, but it has also other elements and other compounds. It has things like methane and ammonia. In fact, the blue is because of the methane that's in this planet.
Okay.
So the
But
methane
again,
kind
all
of absorbs.
gas.
It's gas and kind of ice. It might be
Ice,
kind of a
yeah,
slushy
slush.
material, but it's not. It wouldn't have a solid rocky surface. Certainly, it wouldn't
Okay.
have anything like that. But again, it's a young world. In fact, my colleague, Dr. Russ Humphreys, he's got a model for how God might have started the magnetic fields in our solar system, and based on 6,000 years of decay, he can compute what the current magnetic field is for each of these planets. And he has actually successfully predicted the magnetic field of Uranus before it was measured by the Voyager spacecraft. Wow. And he was right on, because he was starting with 6,000 years. The secularists were way off, because they were assuming it was billions of years old. And so you see how real science, it starts with the Bible.
Yeah.
If you're going to do it right, if you're going to get the right answer, it's got to start from Scripture.
So the gravity of these planets is a testimony to a young Earth.
The magnetic field.
The magnetic field, excuse me,
right.
yes.
Yep, that's exactly right. And you can see there the moons orbit Uranus, and since they orbit around its equator, and its equator is sideways, they orbit sideways too, at least the inner moons. And again, the outer moons kind of do what they want. It's just a common property that we see in the solar system. We saw that with Jupiter's moons, and Saturn's are that way as well. The next planet out, and it's now the final planet in our solar system since Pluto's been demoted, or Plutoed, as they say. The next one out is the planet Neptune, and it's almost a twin of Uranus, really. It's just a bit further away, but it's a large blue sphere, basically 4 times the size of Earth, almost the same size as the planet Uranus. And the interesting thing about Neptune, a number of interesting things. One, it has a dark spot on it, very similar to Jupiter's red spot. But unlike Jupiter's red spot, this dark spot comes and goes. It sometimes fades out. And it could be that the hurricane's still there. It may have just changed color so that we can't see it in terms of the rest of the planet, in terms of its contrast. You can see those lovely cirrus clouds there on the planet Neptune as well. So it's a beautiful planet. It's probably, aside from Saturn, I think it's the prettiest of all the planets, that beautiful bluish color that you have to it. And it, of course, confirms biblical creation in a number of ways. First of all, it has that strong magnetic field, just as the planet Uranus does. And again, it's one that my colleague Dr. Humphreys predicted would exist and would be that strength, whereas the secularists were way off, because they're assuming this planet's billions of years old, and it isn't. It's thousands of years old. Another interesting characteristic of Neptune and also of Jupiter is that they give off more heat than they get from the sun. In fact, they give off twice as much heat, twice as much energy as they get from the sun, which means they're constantly losing energy. And it turns out that in 6,000 years, it's not a problem. They've lost some energy. But if they were really billions of years old, they should be icicles by now. They should have lost all of that energy. And so this internal heat of Jupiter and Neptune is an indication that they're not billions of years old. It's an indication that they're the age that the Bible teaches. So it's just one further confirmation of biblical creation among many.
Yeah. Moons on this one?
Absolutely. Lots of interesting moons. When I was growing up, they knew of 2, and now they know of many more. It's just amazing the kinds of discoveries that we've been able to make.
And that's because we have better equipment.
Yeah, we can see more. It's only got one that's really big, though, and the really big moon is called Triton. And I'm going to zoom in on Triton here. And Triton's interesting because it orbits backwards. It's a large moon that actually orbits. So again, it's an example of God's creative diversity. All other large moons orbit their planet in the same direction the planet orbits, but not Triton. It is backwards. And it has these black geysers, too, that stream up on its surface. And it's just a fun little world that you can see there. And who would have expected that it would behave in this interesting fashion with these black geysers that spew up, and it's got a real thin atmosphere as well. So it's just a fascinating example of God's diversity and His creativity.
Jason, God just won't fit in our box.
No, He won't.
He has an incredible, every time we think we've got the rules, I mean, He has rules and laws of science, rules and laws for us, but we don't have rules for Him.
That's right.
He's always bigger and greater and grander and more creative than we can even imagine.
I think that's what astronomy teaches us.
Is that right?
Yeah.
So what's your takeaway from the outer planets?
That God is a God of creativity, He's a God of beauty, He's a God of diversity, and also a God of order. We see all these things very organized, very logical, and yet there's beauty and there's diversity in them. It's the same thing we find in the living world as well.
Beauty Diversity but order.
That's right.
Yeah, that's awesome. You know, my friends, I hope that as you look at these planets through Dr. Lisle's eyes, that you see what he sees. That you see, first of all, a young solar system, because there are things there that point to the fact that they couldn't be if they were as they are if they were billions of years old. But also you see what we've been talking about, that how just when we think it all has to be this way, God will make it another way. He'll lay one on its side or do something different, put a ring around it to just say, there, that's just for beauty's sake. When you discover that, you'll go awe, and that awe reflects the awe we ought to have for the majesty of God. Remember this, my friend. It's God's view that He created you. And as you look at what He's made, that should be your worldview too. I hope you'll be back joining us again soon on Origins. And until then, God bless you, my friend.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file from our website at www.originstv.org. Or for a DVD of this series, you can order online or send a $12 donation to cover shipping and handling and write to Origins Program Number 1503, Cornerstone Network, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and financial support of you, our Cornerstone family.